I'd like to try the same problem using two different techniques. In either case, I'm going to use synthetic division to find the value of W. So in the first case, let's suppose that we take the traditional path in which we drop the 12 here, and then we go 12 times this, and that would be 28, and then we add these, that'll be negative 15, and then we multiply, and that'll be negative 35, and then we add these, that'll be W minus 35, and then we continue to multiply and put it there and then add, multiply, put it there and then add, multiply, put it there and then add. So let's run through that quickly. So after having run through the synthetic division algorithm using some scratch paper here in the bottom, this is what I got here, and this is my remainder. And given that the assumption is that we are using a factor or the root of a factor of the polynomial, we know that the remainder has got to be 0. So we set this equal to 0 and we solve this equation. Let me move this to this side so that it's 343 over 27 times W equals this number here. And then I can multiply by a reciprocal both sides. A reciprocal would knock that out. The 27s knock out. And on a calculator, you'd see that this works out perfectly. Check that out. It says that W is equal to 14. Can we do this without so many fractions? Yes, we can. And so why don't we try the same problem, but it's going to be done a little differently. But we will get back the same number 14. So let's try it like this. We know that the remainder is going to be 0. And because this is 0, that implies that immediately above, this is supposed to be a negative 21. Because if you add these, it's 0. And so now the question is, how do I get a negative 21? Well, remember that this times this has to be that. This one times this one is this one. Or better put, if I take negative 21 here on a calculator, and if I divide it by the fraction out there, right? If I go this divided by that, then whatever I get, that's the number that goes here. Because after all, this times this gives me that. You see, I'm working backwards, sort of. And so now what does this have to be here? Well, what I can do is I can go this number, negative 9, and I can subtract by the number up there. And I get 56, positive. And that makes sense because if I add these numbers, I get negative 9. And so now to find the new dot, I take 56 and I divide it by the number on the outside. That says 24, and that goes here. And now on my calculator, I go 24 minus whatever is up there, and that's negative 49. And now I take negative 49 and divide it by the fraction on the outside, and that's negative 21. And as a matter of fact, why don't I stop here and go this way this time? You see, you don't have to go completely this way. You can go this way a little and this way a little and like meet in the middle. So let me drop the 12. And 12 times that is going to be 28. And this is negative 15. And that times that is negative 35. And then here is where I stop. You see, right here, once you have this vertical arrangement, you are ready to discover the value of W. Because this goes W plus the negative 35 equals the negative 21. This plus this has to equal that. That's why I created this equation. This plus this equals that. And now I can solve this equation by adding 35 to both sides. And so W would equal 14. So compare it. See that? It's the same answer, 14, but I'll let you decide which method you would like to use from here on moving forward.